compared to the Svelte version, for example, where it'll occasionally have one of those 200 hits, but it's rare. Why are the cold start times so awful? Like, I had one yesterday that was almost a second. React is not the fastest at generating HTML. That's sadly pretty well known at this point. Let's chat performance. We're in the middle of a war of frameworks, deployment methods, SSR, SSG, caching solutions, data storage solutions. Everything's been changing at a rapid pace. And I don't feel like we've taken the time to sit here and talk about how these different technologies affect performance in different ways and which of them do and don't make sense for your solutions. And most importantly, what compromises these different solutions make in order to work. What I'm excited to talk about in particular here is the performance of solutions like Deno Deploy and Vercel's Edge, which is based on Cloudflare's Edge workers, versus Lambda and more traditional server deployments in all of the different modern frameworks that support these deployment solutions. So, with all that said, let's chat performance. The three places that we're seeing the most innovation in performance right now that I'm hoping to focus on here, I guess it's kind of four. Well, we'll start with these three. It's deployment methods. So think serverless, Lambda, containers, Railway, Heroku, ECS, Edge containers. I'll call that this. Firecracker, Fly.io, Deno Deploy, and Edge runtime, Cloudflare, Edge workers. We also have framework, or we'll call this web frameworks. In here we have like Next.js, Remix, Svelte, Astro, Quick, all the different solutions that have server-side rendering options. Many of them now support all of these different runtimes. And we have data storage. And here we have things like Postgres, MySQL. We have caches like Prisma Data Proxy, Redis, ReadySet. We have edge storage like Worker KV. I guess Redis is kind of an in-between of edge storage and cache, but we won't dig too deep into that. So I'm breaking these three things out because these are the major points of innovation at the moment. Deployment methods, data storage, and web frameworks. I am not going to be talking about this one too much during this talk. There's a lot here, and it's changing really fast, and I'm excited to have those conversations more in the future. But I will cross that off quick to make it clear we're not talking about this for now. We're focusing on these two. So, what is there to talk about here, and what's changing? Serverless has been the standard for a bit now, only a few years, but it's quickly caught on with AWS making Lambda runtimes pretty trivial to work in and deploy, and then serverless patterns like Vercel and providers that are really just wrappers on top of Lambda, making it trivial to have a Git repo, deploy on Lambda, and now whenever a request comes in, it spins up your code, handles that one request, and dies. This means you don't have to think about performance. You just think about, or not performance, you don't have to think about scale. When you have these Lambda functions that spin up on request and die right after, you don't have to worry about your servers being provisioned well enough to handle all these requests, because a new server is provisioned and killed on every single request. It means that we don't have to think about the scalability of our API. we do have to worry about the data side, but if you pick a solution like planet scale, you don't have to worry too much. Serverless functions let us not think about the runtimes in which our server code, or the infrastructure in which our server code is running. This comes at costs, though, in particular the spin-up time. In order for a serverless function to respond, if it hasn't been hit recently, it goes through a thing called a cold start, which means the code is being pulled over to that box and then unpacked so it can run. And depending on how much code you have and how complex your environment is, that can take seconds to do. On ping, for example, the cold start times are as high as 2.5 to 3 seconds. So if there isn't a recently hit Lambda available to process your request, it can take up to 3 seconds for that request to come through. And that sucks because our code runs in milliseconds, but our code takes multiple seconds to actually spin up and run on that infrastructure. Containers are, to an extent, the old solution here, where you would spin up a box, you'd give it a thing like a Docker image that says, run this OS, have these dependencies, and process requests in these ways. And then that box would have a request come through, process it, and then reply. If that box couldn't handle those requests, you need to now build a way to scale that up, split out the requests to, how do I put it? You would have to manage the pooling of those requests yourself. So if your box can handle 10 requests at a time, but you have 15 users requesting, you need to spin up a second box and route the traffic fairly between those two and make sure that anything that one server expects, like if you're keeping track of who's in chat, that state gets synchronized between those two servers. You have to think a lot more about the infrastructure in the container world. Ideally, we'll be in a future where we don't have to think about that with containers. But right now, container generally means you're thinking about the relationship between these containers so that you can keep your application running at scale. And managing multiple containers, especially if they're running the same code, is relatively complex. And serverless lets us skip that at the cost of the cold start time and the ability to have stateful applications built into the infrastructure itself. Like in a container, if you write to a SQLite file, it'll still be there because the container exists. In the serverless environment, whenever you make a change, it immediately dies whatever you did on that Lambda. So if you write a file, like you make a text file for every user when they sign in, that file disappears as soon as the request is completed. So you can't do those types of things in a serverless environment, but because of that, you're encouraged to write more scalable solutions inherently because you offload the data somewhere else. Theoretically, if you built a containered solution with a serverless mindset and auto scaling with a good like load balancer on top, you can make something that feels a lot like serverless, but isn't, and has the performance that you would expect from a containered environment. Edge is getting pretty close with there, specifically edge containers, which is what we see with Fly.io with their new Firecracker quick deploy solution to get a box spun up almost immediately, or Deno deploy, where they have servers all over the world that are all smart enough to, how do I put it? They're smart enough to spin up on request, and they're working on caching solutions so that spin up time is really fast. I didn't know that Lambda used Firecracker, Dax. That's actually really good info. Thank you for sharing that. Yeah, I guess Firecracker is being used by Lambda as well. Fascinating. Well, learning a lot as we go. Let's get into this final deployment method. This is the one that is the current rage. Edge containers are catching on again, but edge runtimes have been the thing we're all excited about for a while. This is like what the crew over at Remix is always talking about. It's what like Netlify and now Vercel and all of these deployment companies are talking about. The idea of the edge is rather than a serverless environment where in US West 2, Amazon has a bunch of servers, and when a user makes a request, no matter where they are, that request goes to West 2, they spin up our code, they reply to the request, and then they kill our code. What if our code was running closer to that user? The idea of the edge is there are very small, very light, like not super performant solutions all over the world. And those edge runtimes are much lighter than a containered environment. Like, you're not running Docker in there. You're not running a custom image. You're not running anything other than very vanilla web API-ish JavaScript code. But in those edge runtime environments, there is no cold start. How do I put it? Edge runtimes, by limiting the set of what you can do to standard like JavaScript environment stuff, they're able to run a bunch of JavaScript virtual instances that are already there waiting on like routers, on Raspberry Pis all over the world. And your code runs on the closest one to the user that is available to run it. And it is already sitting there waiting. The environment is ready. It just has to take your code and run it, which makes it a lot faster than serverless. Cold start times in Cloudflare workers, for example, are like milliseconds instead of up to full seconds in a serverless Lambda environment. So the edge runtime is the thing a lot of people are fighting to get to right now, but edge runtimes don't provide all of the things that we expect now as Node developers. There is no edge runtime that is fully Node compatible, which means packages like Prisma do not work on the edge. There are things they're doing to change that, but technically speaking, you cannot run Prisma with its Rust bindings connecting to a SQL database on the edge, because we don't have Rust bindings. We have a JavaScript virtual machine. We can do fetch requests. We can do like data processing. We can run JavaScript code that does something like generate an HTML page and then send that HTML page down the wire. But we can't do native bindings, and we can't do a lot of the Node built-in stuff. So how do frameworks come in here? Well, of these, Remix is edge ready, but doesn't have a Vercel binding yet, and they're not interested in building it, which is annoying. So in order to test Remix, I'd have to build my own Cloudflare deployment for it, and I don't feel like doing that. Svelte has been edge ready for a while. They were the first consumers of the Vercel edge like worker API that now theoretically any framework developer can use to build a binding for edge runtimes for their framework. Astro's had it for a few weeks, actually, which surprised me. Their edge runtime's been really fun to play with. And Next.js, as of 12.2, now supports edge runtimes, but the performance isn't great yet, and we're going to talk about that. Edge runtimes mean you can't use a lot of the things that you're used to in Node, but if your rendering is just pretty basic React JavaScript stuff, you could probably run that part in the edge and fetch data from your APIs that are running in serverless functions. And then you can cache at that serverless layer and generate HTML at the edge layer. Really interesting how I'm seeing these technologies like be split up in a way where they're used for their strengths and skipped for their weaknesses. And Vercel's building towards that, which is very exciting. So why am I thinking about all this? Why am I talking about all this? As we talked about last week, Next 12.2 added edge runtimes for both for APIs and for SSR for generating HTML. And I went a little crazy. I built a benchmark for a bunch of the different Vercel runtimes. I built Edge versus Lambda versus Cache for Next. I built a Svelte Edge version, an Astro Edge version, and then I have the fresh Deno deploy thing I was working on last week as well. This is all in a mono repo, so if you want to see the code, it's in the new T3 OSS open source org. Here are all of the different projects that I have running here. So what does this do? When I open up the page, it makes a request that gets routed through Vercel to an edge. It generates HTML, sends it down. I disabled all of Next.js's client-side JS. So this isn't a React app as far as my browser is concerned. It is just using React in the HTML generation. I did that because I create this on client and not inside of React, and I want this to be accurate as an inline script. And React gets mad when I hydrate the page differently from the page it sent down. All that aside, I also have it local storing the values you get and tabling them. So when you refresh, you can see each request's timings. And what you'll see here is very interesting compared to some of the other runtimes. There is a huge gap where it goes between 200 and 300 milliseconds and 60 to 80, which is very strange. This is the only Edge runtime experience I've had so far that is that inconsistent compared to the Svelte version, for example, where it'll occasionally have one of those 200 hits, but it's rare. It's usually between 50 and 110 or so. It's a much smaller range that I'm seeing for the times here. Svelte did not like me running inline JavaScript, so I had to do some hacky stuff to make this one work. But yeah, the Svelte times are very fast and relatively consistent. I also have the Astro Edge, which is very exciting because, as y'all know, I like Astro a lot. This has a wider range, but is generally very fast, between 50 and 150 milliseconds for me in San Francisco right now. Yeah. So if you want to see how quickly each of these can generate HTML, send it to the user, and then run the inline script I have in here. Where did I put that script? Did the script get auto-hoisted? It does. That's cool, actually. Deno is the only thing that does this for me. All the others I had to do much hackier stuff to put my own script. Very nice. It's not Deno. Astro was the only thing that did this like correct, and I'm very happy with it. This is SSR. That's why I have the rendered at here. That's coming from the server because I wanted to be sure this one in particular was actually running like with SSR. So that's why this one has a time and the others don't. This is just to confirm because Astro is very static and this was confirming it's dynamic. So the JavaScript here got minified, so I can't show it off too easily. I can go to GitHub and show it there. Astro's has the least awful source of the bunch. So I'm going to go here. Here's the script. So current time is new date. So this is an inline script that should run almost immediately. Full time is current time minus windows.performance.timing.request start. This is what the window believes is when the request started. This is the most accurate way I found to get the timing from when the script runs in the browser relative to when the request started. I then override this ID in the HTML, and now we have that number. I also, and this has been a little more painful if we look at how I did this in Next, for example, since I'm not running Next's JavaScript because that would be very slow and not give me the number I'm looking for. I actually had to inline this script as a string and then disable server or client-side JavaScript from the Next bundle entirely so it doesn't override this in jank ways. All of this was necessary for us to do the benchmarking as I please. I'm getting a bunch of messages from people that I am incorrect about Deno deploy being Edge containers. It's closer to Edge runtimes. My confusion there would be, and I know y'all are here, so please give me the deets. Why are the cold start times so awful? Like I had one yesterday that was almost a second, 786 milliseconds. This is like actually worse than some of the cold starts I get on the Lambda version here. I had a couple that were in the second range, but not many. Usually the cold starts for a vanilla Next project are like 300 to 500 milliseconds for me. So I was really surprised to see these big numbers come up here sometimes. No, these will not hit a cold start ever again because I just showed them on stream and people are going to be going to these URLs forever now. But yeah, I did just make this a lot harder for myself to bench, so I should plan around that in the future. Can we get a cold start from it? No, I'll never see a cold start on this again. Who am I kidding? Yeah, the cold start times I was seeing were not great, and I am very curious how that could be the case if you guys are using V8 isolates. Okay, there's a file system read going on in Fresh on cold start, and FS reads are not as globally distributed as your compute. Interesting. Very interesting. It seems to be that the read is the slow part here. That's exciting. That sounds solvable. I'm going to not complain too much about Deno deploys cold starts until that is a little closer to being solved, because that's exciting. Yeah. Anyways, the main reason I did this is, I guess it's twofold. Goals of bench.t3.gg. I had a couple specific questions I wanted to answer with this project. What is the perf diff between lambda edge and Deno deploys hybrid approach? I guess it's not that hybrid, but I at the time was under that assumption. I'm still trying to figure out that. I also, what were the other questions? How big a bottleneck is React in, how do I put this? In server renders. React is not the fastest at generating HTML. That's sadly pretty well known at this point. React is not fast. React is fast enough, but when it comes to getting HTML to a user as fast as possible, React probably isn't the fastest way to generate that HTML. There's some exciting stuff going on in the space for that. In particular, Bun by Jared is very exciting. We'll have him on the show soon to talk all about Bun. It releases in the next day or two, if I recall, so that'll be a stream happening in the near future. I think he's going to help a lot with like the writing of a renderable HTML string in a stream. I don't know how much that will help for React's server-side SSR performance overall, but it is very exciting stuff and should be a cool future. I am more interested now in how big is the penalty for React compared to faster JavaScript runtimes like Astro or Svelte specifically. So, how do we figure that out? From my current understanding, sadly, Next is adding a relatively significant penalty to the speed at which the React code can run and reply. I want to test React on the server in the most ideal environment. Sadly, I can't do that because I can do that. It's just a lot of work. Thankfully, as Lee leaked to me earlier today, sadly the source is not available, but this is a fresh like pseudo framework trying to generate an HTML page in React as fast as possible using ESBuild and a bunch of other junk. So since I don't have my timer built in here, we're going to hop over to the terminal. The only thing Vercel's married to is web performance. Never underestimate them, Maple. Cool. Total 91, 99. Cool. If I grab mine to compare. Yeah. We're talking double the time there compared to the Svelte one. Okay, these are closer than I would have expected. React a bunch more. Svelte again. Yeah, that's not as big a difference as I would have expected. React again. Yeah, okay. So, fascinating. It looks like there's a significant penalty between, there's like a 20 to 30 millisecond difference from what I'm seeing here, just with the quick numbers, doing math in my head and not actually collecting data here. About 20 to 30 millisecond difference between Svelte and React in this custom React environment. Whereas Next takes 80 to 100 millisecond penalty on top of that, which is huge. There's definitely optimizations to be made in all of these, but Next in particular stands out as needing of some significant innovation on their runtime. Because right now, I've actually gotten better times on the Lambda than I do on the Edge pretty regularly, which is scary. We just went from 40 milliseconds to 378, down to 50, back to the 200s to 50, 40, 200. Yeah, I do live very close to an AWS data center. That is a very good point that I've seen made a few times. I am in SF, and West 2 is not too far. But the Edge should be pretty close as well. Should be. So, yeah. Now that I've seen the timing of this guy, and I really need to like put together a proper benchmark where we bench React on the Edge against Next on the Edge against Svelte and Astro on the Edge. Just run it like 500 times, ideally in a few different regions, and then compare all those numbers. I don't feel like doing all that. That said, clearly when I say things in front of my community, y'all go and do awesome stuff with it. So with all of this stuff deployed and enough Vercel employees here to make sure that our open source Vercel account, T3OSS, doesn't go over the Edge runtime limits, I would really love for somebody in the community to get us some good numbers benchmarking these things and see what it's like overall. You have all the pieces here. This is the missing one that I wish I had the source for. React on the edge.vercel.app. The rest of these I built. This one Guillermo built. Hopefully we'll have source soon. So if anybody wants to bench all these and see what the numbers look like, please do. Let me know how that goes. Genuinely super curious. Oh, one more spicy flavor. The cache version. This one will always fly because this is on a CDN because this HTML was built when Next.js like initialized the project and put it on the servers. So it's basically impossible for this to ever go over 100 ms. There's a source link on this, but it's broken. This was an early leak. We probably shouldn't have had this, but Lee was a bro and gave us access to this early so that I could use that because I wasn't happy with Next's numbers and I did not want to find another way to run React on the Edge that wasn't like also an Astro benchmark. Edge in this context means the Vercel Edge, which specifically means the Cloudflare Edge worker infra and runtime. So it's running on a Cloudflare V8 isolate, which is a V8 container that has access to most of like the web JavaScript stuff, but none of the Node.js native bindings, things like FS, crypto, all the things that we use in Next.js or in Node.js all the time, it does not have access to. So it's a fully different runtime compared to Node. Lee Rob just linked in chat the Edge runtime available API, so you can see all the things you can do in the Vercel runtime. I didn't forget to talk about Quick. I put it here because it's a thing that exists that is interesting. I don't know much about its runtime experience right now, especially its weird hydration patterns. It's very different. I want to dig in on it way more first before we talk about it. I put it here because they are thinking of all this a little bit differently, where it's like partially static, partially cached, partially dynamic, all done on the server with minimal hydration on the client. I don't think it's going to be meaningfully different in performance here. It's more focused on the client side. So I should put that here. Performance of modern server solutions. Cool. Pronounce Vercel or Vercel like parcel. Varcel. Love that. Or Vercel. Either way. Did you know that over half my viewers haven't subscribed yet? That's insane. Y'all just click these videos and listen to me shout and hope that the algorithm is going to show you the next one. Make sure you hit that subscribe button, maybe even the bell next to it so that you know when I'm posting videos. Also, if you didn't know this, almost all of my content is live streamed on Twitch while I'm making it. Everything on the YouTube is cuts, clips, whatever from my Twitch show. So if you're not already watching, make sure you go to twitch.tv/Theo, where I'm live every Wednesday around 2 or 3 p.m. I go live on Fridays pretty often as well. Thank you again for watching this video. Really excited. Thank you.